Alright, we're going to continue on with some more u substitution. And the next example here is going to be another definite integral from 0 to pi over 2 of sine squared theta, cosine theta, d theta. Alright, so what is the thing that's giving us the most trouble? Well, if it was sine squared theta, we wouldn't be able to integrate it. So that's the thing that's giving us the trouble. If it was just cosine theta, we would be able to integrate it right away. So what we're going to do, especially since we can write sine of theta as sine theta squared, we're going to let u equal the thing inside the parentheses. And that's typical in the past couple examples. That was the same story. We find the differential just like before. The derivative of sine is cosine, and then we have d theta. And then look, we got a cosine theta, d theta right in there, so we don't even have to do some extra algebra. Okay, so now we're ready to do the u substitution. However, we see that there's limits of integration. So we can either solve it in general or change the u's. So let's do it this way. Let's do it in general, and then we'll substitute back in for the limits of integration. Now, like I said, you can do it either way. Just keep that in mind. So we're going to do it in general. Alright, so we're going to substitute in. Instead of sine theta, we got u squared. And then instead of cosine theta d theta, we have du. We can integrate that just with the power rule. We get u cubed, and then 1/3 out front, and then plus c. We substitute back in for u, and we get sine cubed theta plus c. There we are. Now let's substitute in our limits of integration. So we have this is our original integral. Okay, when we substitute in, you get 1/3 sine cubed theta. The fundamental theorem of calculus says you evaluate it from 0 to pi over 2. Alright, so we're going to substitute in pi over 2 first. We get 1/3 sine cubed of pi over 2. And then we subtract 1/3 sine cubed of 0. Alright, so sine of pi over 2 is 1, so we get 1/3 times 1 cubed, minus sine of 0 is 0, so we get 1/3 times 0 cubed. Expanding, we get 1/3 minus 0, and that is just 1/3. Now, the other way where you change the u's, I'll let you do that if that's what you want to do. And let's move on to the next example. Okay, so next example here is the integral of 2x plus 1 and then x dx. We see a square root. Typically, what's underneath the square root is what we let u equal. And we find the differential, so it's 2 dx. We don't have that in our integrand, so we're going to divide by 2 on both sides. And there we go. So let's do the substitution. We get the integral, we got the square root, and then we have, instead of dx, we got 1/2 du. However, we have an extra x in here still. The du didn't have an x in it. So then we have to take a step back and, well, we can't integrate this, right? Because we need all u's in our integrand. So then we look back at our u and see if we could potentially get x by itself. And this one's pretty nice because we can just do a couple things to get x by itself. So let's subtract 1 on both sides, so we get u minus 1 equals 2x, and then divide by 2 on both sides, to get x by itself. And so we get u minus 1 divided by 2 equals x. And so we're actually going to substitute that in for x now. So 3 substitutions here. So this part is going to stay the same. But instead of x, we're going to write u minus 1 over 2. Alright, so this is our integral. Let's try to clean it up a little bit before we integrate. And we notice that we only have u's in it. So we should be able to integrate now. So we got a 1/2 and another 1/2. So here and here. Let's take that out of our integrand, and so that's going to become 1/4. And then we have the integral of the square root of u times u minus 1 and a du. Now, we should be able to integrate this, but let's make it so that we can use the power rule real easily. So we'll distribute that square root. So we got 1/4, and then we have u to the 1/2 times u, so that will give you u to the 3/2. And then we have the square root of u to the 1 times 1 is the square root of u. So u to the 1/2, and then we have du. So now we can use the power rule. So we got 1/4. We're going to integrate u to the 3/2. 3/2 plus 1 is 5/2. And then we multiply by 1 over the new exponent, so the reciprocal. And then we subtract u, and then we have 1/2 plus 1 is 3/2. And then 1 over the new exponent is 2/3. And then we have plus c. Alright, then to finish it up here, we've got to substitute in for u. And before we do that, why don't we distribute this 1/4? So when we distribute, we get 2 over 20, and then u to the 5/2 minus 2 over 12, u to the 3/2 plus c. Let's substitute in, and I'm going to move over here since I've got the space. We can simplify that first fraction to be 1 over 10. U is 2x plus 1 to the 5/2, and then we have minus 1 over 6 when you simplify the fraction. Substituting in, we get 3/2 again, plus c, and there we go. There's our integral. Okay, so we got nice examples here for u substitution. So we're going to have some homework with that, and